Hello, I am Umang Barnawal from second year EC department. Today we are going to break down a super important topic from signals and systems, classification of signals. We will see all types of signals, their mathematical form, graph and significance in the simplest way possible. So let's get started. First of all, what is signal? A signal is a bridge between a source and its destination. It is a mathematical representation of a physical property which carries some information. Here is the graph of a signal, and you can see it is sinusoidal graph. Now, the significance of signals. We can see in the communication sector, without signals, devices like phone, radio, satellites will not work. And also in control systems, machines like washing machine, traffic lights are also relies on signals. Even in measurement, sensors send signals to tell us temperature, speed, or other values. In data processing, signals can be stored, analyzed, or transformed for research. In energy transfer, signal can also carry energy like electromagnetic wave. So you can see, in short, signals are must thing in our daily life. So let's move on the type of the signals which we will see in the whole video. So let's get started. Types of signal. There are various types of signals we will see in the video. So let's get started and read all the signals we will. Like first of all, based on the continuity of independent variable, continuous time signals, discrete time signals. Continuous time signal. This signal is defined for every value of time in the given interval. It is generated by x to the function of t. X is equal to signal amplitude, t is equal to time, which is variable. Example is xt is equal to a sine omega t plus phi, where phi is equal to phase and omega is equal to angular frequency. The properties of continuous time signal is time variable, t is continuous and used in analog system. As you can see the graph of this signal, that it is a continuous graph, and we will write this graph without putting up our pen. So let's move on to the next type. Discrete time signals. Definition. The signal is defined only at specific and distinct point in time. It is denoted by x, the function of n, where x is equal to signal amplitude and n is equal to integer representing discrete time steps. Example, xn is equal to a sine omega n plus phi, where phi is equal to phase, omega is equal to angular frequency. As you can see, that the graph is just broken and it is only shows value on a specific value of n, and here n is an integer. Here n is an integer, so it is an interval where you will find the value of the function for n. Okay, let's move on to the properties. Here n is discrete and used in digital systems. So let's move on to the next type of signals. So next is based on amplitude nature. Analog signal and digital signal. Here analog signal. It is continuous time signal whose amplitude can take infinite values in given interval. It is denoted by x, the function of t. The example of this is xt is equal to a cos 2 pi phi t plus phi. A is equal to amplitude, f is equal to frequency, and phi is equal to phase. It is used in the output of the microphone. As you can see the graph, it is a sinusoidal graph which represents cos 2 pi phi t plus phi. Now, digital signal. Definition. A signal whose amplitude takes only discrete values like binary is 0, 1, and xt is equal to 1 on high level and 0 on the low level. As you can see on the graph, either it is 1 or 0, nothing between them. Like it is used in computer binary data and digital clock readings. So we are done with the reading of basic analog signal and digital signal and various types of signal. So let's move on to the next type of signals. Now, based on symmetry, even signals and odd signals. Even signal. Definition. A signal that is symmetric about vertical axis. Here the main significance of this signal is x minus t is equal to xt. So if we put minus t on the value of t, the signal, the function will redeem itself like cos t. As you can see the graph, it is vertical. Yeah, it is symmetric about vertical axis. It used in Fourier analysis. Now, odd signals. A signal that is unsymmetric about vertical axis, and the main highlight of this signal is x. If we put minus t on the position of t, we will see that the function will be whole negative. So the example of this is xt is equal to sin t. As you can see the graph, the part above vertical axis is equal to the part above below the vertical axis. So the main highlight of this is the area of this of these curves of odd signals will always be 0. Yeah, and the properties of this signal decomposition. So let's move on to the next signal. Next, based on energy and power, energy signal and power signal. Energy signal definition: finite total energy is always less than infinity, and P is equal to 0. We can see total energy is equal to limit t tends to infinity, integration minus t to t xt mod to the power 2 dt. It is mainly typically non-periodic, and you can see the graph of it. Now the power signal definition is finite average power and infinite energy. E less than infinity and P less than infinity, and E always tends to infinity. And you can see the expression of this is P is equal to L limit n tends to k 1 by 2n plus 1 sigma n is equal to minus n to n xn mod to the square. And the example of this is xt is equal to a sine omega t, and the graph of this is like a sinusoidal wave. So now we will move on to the next type of signal. So let's do. Now, based on periodicity, periodic signal and aperiodic signal. In periodic signal, you can see that xt is equal to xt plus t. Here t is time period that can be any value like negative, positive, 0. And here the format xt is equal to sine 2 pi phi t and t is equal to 1 by f. The main motive of this signal is that for a specific value, if we add a specific value to the function, and if it will repeat itself after summation of that value, that it is a periodic signal. Like if we put sine 2 pi phi t plus 2 pi, then it will the function will redeem its value again. And this is used in oscillators, and as you can see the graph. Now aperiodic signal, xn is equal to xn plus n, where here n is equal to period, but here's a catch that it only belongs to integer, where in periodic signal it can be decimal, it can be rational number, it can be irrational number, but here it has to be integer. Now here you can see xn is equal to cos 0.01 pi n. This is a simple example of this aperiodic signal. Now the significance of this, it doesn't repeat, it represents finite length. Now we'll move on to the next type of signal. So let's do this. This is the last type of signal, based on determinism. Deterministic signal, random signal. Deterministic signals can be defined by mathematical equation. The signals that can be defined by mathematical equation is deterministic signal. Now you can see the example of this. Xt is equal to 5 cos 10t into e to the power minus 0.2 into t. This is a general expression or a general example for anyone who can see. Easy, and it is easier for calculation and analysis, as you can see the graph of this function mentioned above. Now the last random signal. Signals cannot be defined by mathematical equation, means you can't define these type of signals by mathematical equation. It can also be seen by graph or graph things, but not by mathematical equation. And the example of this is noise, so you can't define noise by mathematical equation. And it is not easy for calculations. So this was the whole video for signals and system and classification of signal. Hope you will enjoy the video and you will like the video, as I I also